My name is Seungjae Lee, and I'm in master's course at Professor Jinung Kim's Advanced Biohealth Material Lab. Today, I'm going to introduce my field, interface chemistry and rheology. This is my presentation context. I will first share my research background and some keywords, and explain the field these studies are used. And lastly, I will briefly demonstrate my current works. ABML, my lab has four main themes of research, and I'm taking part in interface engineering. To start with, I want to introduce interface chemistry. Interface is area where two immiscible phases come into contact. Interface chemistry focus and study this thermodynamically unstable region. When we try to mix water and oil by shaking, it seems it is mixed for a short time, but soon they are separated in two phases. This is because small oil droplets in water phase have large surface area with large energy. They try to reduce surface energy by reducing surface area, which eventually ends in phase separation. But when we add surfactant, which is amphiphilic materials, which can absorb into the interface and reduces surface tension, it might reach to a metastable state and stay dispersed. Interface engineering studies surfactant in various forms such as fibers, platelet, sphere particles, polymers, etc. to stabilize or make emulsions. We synthesize amphiphilic materials for specific purpose and evaluate. Surfactants are used in many places, starting from simple soap to cosmetic products. I am also studying the rheology of fluids. Rheology is a study of deformation. Rheology researches how materials react when force is being applied. Simple example is viscosity. There are other parameters to demonstrate the behaviors of materials toward stress. Storage modulus is a parameter explaining the amount of energy stored temporarily by a material. On the other hand, loss modulus is showing the degree of material losing and dissipating energy applied on them. For understanding, extreme case of material with high storage modulus is rubber, which is capable of keeping force applied into usable form. An extreme case of material with high loss modulus is rigid solid, which does not keep any energy upon applied. Most cases, materials shows both characteristics at the same time and behave in viscoelastic way. These characteristics can be measured precisely by a rheometer. Rheometer applies stress through the discs and measures the deformation of samples. Fluids show many reactions upon shear or stress. There are mainly three types of behaviors. Shear thickening, which becomes thickened as more stress is applied. Shear thinning, which becomes thinner as more stress is applied. And Newtonian fluid, which has constant viscosity. These particular behaviors are induced from reorganization of fibers or particles dispersed in fluids. Among shear thinning materials, some materials requires time to restore to original physical properties. These materials are categorized as thixotropic materials. These two graphs illustrate thixotropic behaviors. When high shear is applied, viscosity of material drops. This is shear thinning behavior. When the shear is removed and changed to lower shear, thixotropic material need time to restore original viscosity, while non-thixotropic material restores to original viscosity right after the high shear is removed. Example of thixotropy is a paint. When a paint is stored in a can, it becomes solid form. When paint is stirred, the shear of stirring makes shear thinning paint to become less viscous and become liquid form, which is easy to be spread and painted on wall. But after some time, the paint becomes solid-like form and does not flow on wall. From now on, I'm going to explain where interface chemistry and rheology is applied. Interface chemistry is involved in fields which use immersions. The most famous example is the cosmetic industry. Cosmetic products are mostly immersions. In order to prevent product from losing well-dispersed state and get paste separated, interface chemistry is used. Cosmetic product uses finely engineered surfactant and controls continuum condition to keep the immersion stable for 2 to 3 years under harsh conditions. Interface chemistry also takes place in immersion polymerization process for plastic production. This is the example from Chanel, which succeeded in making cosmetic products with very large immersion. Rheology is applied in field where texture of product is important. Also, cosmetic industry and food industry uses rheology to enhance consumer experience. The rheologic behavior of cosmetic product is engineered for texture and convenience. For example, we can design shear thinning cream to make cream stay in gel-like form when storing, not even flowing on the finger, but easy to be spread by the rubbing stress. From now on, I will explain my recent works. Nowadays, I'm working on making nature-oriented thickening agents. I'm using cellulose nanofiber with metal organic membrane laid on it. Zinc ion is attached to tempo-oxidated cellulose nanofiber by electrostatic attraction. Pietic acid then forms layers by coordination bonding with zinc ion. As a result, cellulose nanofiber is coated with zinc ion and pietic acid layers. These coated fibers shows strong interfiller association by using zinc ions in the medium. The viscosity of MOM TOBish is increased more than 10 times comparing to TOBish with no MOM layer. The viscoelastic behavior of MOM TOBish is further studied with rheometer. I have confirmed over 1,000 times increased storage modulus of MOM TOBish compared with neat TOBish. This shows the strong chemical friction is induced between MOM layers of fibers. The time required for MOM TOBish to restore original state was modeled with a stretched exponential model. The more pietic acid is coated on the fiber, the more time required to regain original state. These results show the changes in MOM TOBish behaviors. The more pietic acid added, the more time was needed to rebuild the original structure. It became more thixotropic. Today I briefly explained the field of my study, interface chemistry and rheology, and demonstrated recent work thickening agent with thixotropic behavior.